While the world was busy staring at thermometers, obsessing over record-breaking heat waves, and arguing about summer temperatures, something far bigger was quietly stirring beneath the surface of the Pacific Ocean. A slow, invisible shift in ocean temperature was rewriting the rules for global weather months before anyone would feel its full effects. This is the story of El Niño, the phenomenon that just went from whisper to roar in a matter of weeks, and why scientists are now warning it could become one of the strongest events ever recorded. To understand why this matters so much, you first need to understand what El Niño actually is. It is part of a natural climate cycle known as the El Niño Southern Oscillation, or ENSO, which swings between three states. There is El Niño, the warm phase, where sea surface temperatures across the central and eastern equatorial Pacific rise above normal. There is La Niña, its cooler opposite, and in between sits ENSO neutral, a kind of calm baseline where neither pattern dominates. This cycle typically repeats every 2 to 7 years. But what happened this year caught even seasoned climate scientists off guard. Just months earlier, the Pacific was sitting in La Niña territory, the cooler phase, with weekly ocean temperature anomalies pointing in the opposite direction of what we are seeing now. Then, in a remarkably short window, everything flipped. Surges of strong westerly winds near the equator in the western Pacific, known as westerly wind bursts, began pushing warm water eastward with unusual intensity. One of these bursts in early spring was described by climate experts as one of the strongest recorded in decades. T-Hat's single atmospheric event helped trigger a rapid warming cascade across the eastern Pacific. And within just a couple of months, ocean temperatures crossed the threshold needed to officially declare El Niño conditions. By early June, the National Oceanic and Atmospheric Administration confirmed what many forecasters had been anticipating, nervously for weeks. El Niño had arrived, and sea surface temperatures in the closely monitored Niño 3.4 region were already reaching record warm levels for early June. Some of the highest recorded since satellite monitoring of this kind began in the early 1980s. That alone would be notable. But what pushed this story into headlines worldwide was the forecast for what comes next. According to NOAA's latest projections, there is a 63% chance that this El Niño intensifies into what scientists call a very strong event between November and January, with sea surface temperature anomalies potentially exceeding 2 full degrees Celsius above average in the monitored region. If that threshold is crossed, this could rank among the most powerful El Niño events ever documented, sitting alongside historic episodes that reshaped global weather, patterns for months at a time. In other words, while everyone was busy watching this year's heat waves and treating them as an isolated summer story, the ocean itself was already setting the stage for something with far longer-reaching consequences. So why does this matter beyond a chart of ocean temperatures? Because El Niño does not just warm the Pacific. It fundamentally reshapes the atmosphere above it, and that reshaping ripples outward across the entire planet. During a strong El Niño, warmer waters in the central and eastern Pacific altered the position and strength of the subtropical jet stream, that high-altitude river of fast-moving air that steers storm systems around the globe. The jet stream typically becomes more robust and stretches further into regions like the Caribbean and the Atlantic, shifting storm tracks in ways that can bring drought to some regions while dumping unusually heavy rainfall on others. One of the clearest examples already unfolding is the Atlantic hurricane season. Normally, forecasters brace for an active season filled with tropical development. But this year, NOAA has maintained a forecast for a below-average Atlantic hurricane season, specifically because of the influence of this intensifying El Niño, strong El Niño. Events tend to increase wind shear across the tropical Atlantic, essentially tearing apart the conditions that hurricanes need to form and strengthen. NOAA's most recent outlook actually reduced its storm predictions even further from earlier in the year, now expecting between 7 and 13 named storms, with only 2 to 6 becoming hurricanes, and as few as 0 to 2, reaching major hurricane strength. NOAA even raised the probability of a below-average season significantly in its most recent update, a shift attributed almost entirely to this ocean pattern quietly working in the background. But if you think this story is only about fewer hurricanes, that is only scratching the surface. El Niño's true influence stretches into winter, when its effects become most pronounced across the globe. During a typical El Niño, winter, the jet stream over the North Pacific tends to dip southward, dragging the storm track across the southern United States. This tends to bring wetter conditions to states along the Gulf Coast and the southeast, while regions further north, including the northern Rockies and the Ohio and Tennessee valleys, often see drier than usual conditions. Meanwhile, temperatures across the northern United States frequently trend warmer than average during El Niño winters, a pattern that could once again reshape everything from energy demand to agricultural planning in the months ahead. The effects do not stop at the American border either. In the Pacific Northwest, agencies are already projecting how this strengthening El Niño could shift precipitation patterns heading into the winter months. Current outlooks suggest a higher probability of below normal precipitation across parts of Idaho, Oregon, and Washington, while Alaska could see the opposite, with a greater likelihood of above normal precipitation. For a region where water availability directly affects agriculture, hydropower, and wildfire risk, a shift like this carries consequences that extend well beyond a single season. And if this kind of deep dive into how our planet's climate machinery actually works is something you enjoy, do not forget to like and subscribe, because there is a lot more of this story still to come. What makes this El Niño particularly fascinating to scientists is not just its strength, but its speed. Typically, El Niño events develop gradually through spring and summer before peaking in winter. This one pivoted unusually fast, moving from La Niña conditions to a declared El Niño in a matter of months rather than the more gradual buildup scientists often observe. Climate researchers have pointed directly to those record-strength westerly wind bursts as the trigger, essentially acting like a powerful shove that accelerated warm water eastward far faster than the typical seasonal drift. It is worth pausing here to underline something forecasters repeat every single time an event like this develops. Every El Niño is different. The underlying mechanism is the same, warmer than average waters in the equatorial Pacific altering atmospheric circulation worldwide, but the timing, magnitude, and geographic fingerprint of each event varies. Stronger El Niño events make certain impacts more likely, but they do not guarantee them with certainty. Climate scientists are careful to note that El Niño is only one piece of a much larger, constantly shifting global weather puzzle, interacting with other atmospheric and oceanic patterns in ways that can amplify or dampen its typical effects. Still, the historical track record of strong El Niño events gives researchers a solid foundation for concern and preparation. Previous powerful episodes have been linked to significant global disruptions, from altered monsoon patterns across Asia to drought conditions in parts of Africa and Australia, to shifts in fish populations along the western coast of South America, where the phenomenon actually gets its name. Fishermen off the coast of Peru centuries ago were among the first to notice the periodic warming of coastal waters, often occurring around Christmas time, which inspired the name El Niño, referring to the Christ child, since the warm currents tended to arrive during the holiday season. As this event continues developing through the second half of the year, monitoring agencies around the world are watching closely, updating their forecasts monthly as new ocean and atmospheric data comes in. Satellites continue tracking sea surface temperature anomalies across the tropical Pacific in real time, feeding into complex climate models that attempt to project just how intense this event will ultimately become by the time it peaks in the coming winter months. For now, the numbers point toward an increasingly confident forecast of a strong, possibly historic El Niño, one capable of leaving its mark on global weather patterns well into next year. What makes this story so compelling is the contrast between what people were paying attention to and what was actually unfolding beneath the surface. Headlines this year focused heavily on scorching heat waves, record-setting daily temperatures, and the visible, immediate discomfort of extreme heat. Meanwhile, thousands of miles away, in the vast, quiet expanse of the tropical Pacific Ocean, a much larger and longer-lasting climate story was building momentum, one that will likely shape weather patterns across multiple continents for months after this summer's headlines fade from memory. That is the nature of El Niño. It does not announce itself with a single dramatic event the way a hurricane or a heat wave does. It builds slowly, silently. In ocean temperatures, most people never think to check, and then reveals its influence gradually, through shifted storm tracks, altered rainfall, and temperature patterns that ripple across entire continents. By the time its effects become obvious in daily weather, the pattern driving them has often been building for months already, hidden beneath the surface of an ocean most of us only see from the shore. As winter approaches, and this El Niño continues strengthening, the real test will be just how closely its impacts match the historical patterns scientists have observed in past strong events. Will the Gulf Coast see the wetter winter typically associated with a El Niño? Will the Northern Rockies face the drier conditions forecasters are already projecting? Will this rank among the strongest El Niño events ever recorded, reshaping global weather the way past historic episodes have? The ocean has already given its answer by warming faster and further than almost anyone expected. Now the rest of the world simply has to wait and see exactly how far that warmth will reach. There is also a slower, less visible story running underneath all of this, one that ties directly back to the broader conversation around a warming planet. Scientists studying long-term ocean data have noted that El Niño events are not occurring in isolation from the backdrop of global climate change. Rising baseline ocean temperatures worldwide mean that even a typical El Niño now has the potential to push sea surface anomalies into record territory faster than in past decades. This does not mean every El Niño will automatically become historic, but it does mean the starting point from which these events develop has shifted, giving each new event a slightly higher ceiling to reach before it even begins. That shifting baseline is part of why climate agencies update their outlook so frequently, sometimes on a monthly basis, rather than issuing a single seasonal forecast and waiting to see what happens. Each new batch of satellite data, ocean buoy readings, and atmospheric pressure measurements gets folded into increasingly sophisticated models, refining the probability estimates in near real time. What began as a 62% chance of El Niño forming back in the early summer has since evolved into a confident declaration that the event is not just present, but actively strengthening toward a potentially historic peak. For everyday people far from the tropical Pacific, all of this can feel abstract, numbers and percentages describing something happening in an ocean thousands of miles away. But the reality is that these shifts eventually show up in tangible ways, in the price of certain crops affected by shifting rainfall, in insurance calculations tied to hurricane risk, in the length and severity of wildfire seasons shaped by drier winters, and in the simple, everyday experience of whether winter feels unusually mild or unusually wet in a given region. The Pacific Ocean does not need headlines to influence daily life. It simply needs a few degrees of temperature change, sustained over several months, to set off a chain reaction that touches nearly every corner of the globe. That is ultimately what makes this story so important to understand right now, before winter arrives and its effects become impossible to ignore. The heat waves that dominated headlines this year were real, and their impact on daily life was immediate and visible, but the quieter shift happened. Beneath the surface of the Pacific Ocean may end up shaping far more of the world's weather in the months ahead than any single heat wave ever could. While everyone was watching the heat, the ocean was already rewriting the forecast for the rest of the year.